I'm going to start 30 seconds early because I have 40 minutes of content to pack into 20 minutes, so I'm just going to fly right through this. Hi, my name is Doug. I'm a developer advocate with the Firebase team, and I'm so excited to be here with you today. This is the first time I'm giving this talk. I'm going to give this talk a bunch more times, so this is actually the redacted early version. I'm going to blow through it. As many of you know, Firebase is Google's mobile application development platform. There are a bunch of tools here to help you build, grow, and understand your app. There's a lot more that can be talked about in one session, but I'm going to focus on Cloud Firestore and real-time database. They are both cloud-hosted, real-time, NoSQL databases. What does that mean? Well, basically all your data lives in the cloud. You use an SDK to access the data. It kind of works like this, where one client writes data into the database, and then every client who is also listening to that same location can receive the updates in real time. So you have one writer, many readers, or anyone can read and write, doesn't matter. It's really easy to get started with. The SDKs are fun to work with. I'm actually in the developer relations team, so those of us in DevRel are responsible for doing things like code samples, tutorials, videos. We make it easy to use. The engineers build it, we have to explain it to people. So we end up with little code samples like this. This is a relatively straightforward code sample that deals with Firestore. So you have on the first line a singleton instance, and you build a reference to a document that you're interested in. You call get on it, and then there's listeners where you can get the data. Now this is a very simple, straightforward example, but it doesn't say much about how to build your app. For example, this is a singleton right here. This Firebase Firestore is a singleton. How do you manage singletons? Well, in the Firebase team, we don't know. We don't care. We're not here to tell you how to build your app. This call right here, get is asynchronous. It returns immediately and you attach listeners to it. How do you do asynchronous programming in your app? I don't know, I don't care. We're just providing a simple example. And then when data actually comes back to your app, what do? Do you just reach right into your views in this listener? Again, that's not our opinion to say how you should build your app. Firebase is not opinionated about your architecture. I'm not going to be here to tell you you should use this dependency injection, you should use what are my options? MVP, MVC, MVVM, QVC, FTP, I don't know. Use whatever you want to use. Your architecture is your architecture. We sit over there, your views sit over there. We don't care about this, we only care about that. You can use whatever you want, but sometimes it's helpful to know from the perspective of a Firebase engineer, what would you do for architecture? And fortunately, we have a lot of opinions about that, and the Android team is actually very opinionated about this now. So now we have a suite of tools called Jetpack that try to give you some guidance on how to do your app architecture. Now there's way more here than I can talk about in 20 minutes. I'm going to focus on two of them. Whoosh, magic move. I'm going to talk about LiveData and view model. So LiveData is a way to notify your views when something changes in your database. And view model lets you manage UI-related data in a lifecycle conscious way. Now these are the soundbite versions. There's a lot going on behind here. So if you recall, I think LiveData works very well with real-time database because real-time database monitors changes in your database and sends them to your app. This is a perfect fit with LiveData. This is exactly what LiveData does. It listens for changes from something and reflects them in your app. Now, if you've downloaded the sample app, I have the sample app that illustrates how I would build an app if I were doing it with Jetpack. You can see it's kind of a fake stock tracker app, so the numbers are constantly changing. Everything is happening in real time. All the data on all your apps should all be synchronized. This is an actual working example, and it uses both Firestore and real-time database. I'm going to talk about, is that my music? This is very nice. It's adding mood to my talk. I'm going to talk about Firestore more than real-time database because Firestore is the new hotness and it's in beta. Anyway, this is what it looks like in Firestore. There is an implied organization with all of your data. You have collections, and within collections you have documents. So on the far left, there's one collection here called Stocks Live. Within that, there's a bunch of documents ID'd by their ticker. And within that, over on the right, you can see that there's fields, there's a price and a timestamp, and within that, there's another sub-collection. So recent history is a sub-collection. If I click into that, there's even more documents, and there's a history of all stock prices here. So this is kind of how my data is structured. Firestore is kind of opinionated about how you should structure your data, unlike real-time database, which is just one giant JSON document. So here's how you would write some code if you want to handle stock price changes live from Firestore. So you would write a line to get the Firestore instance. You would reach into the collection called Stocks Live and into the document ID'd by the ticker. Then you would add a snapshot listener to that. The snapshot will receive either a snapshot or an exception. So if you get a snapshot, what I can do is create a simple model object. So stock price is just a Kotlin data class, and it has a ticker and a price associated with it. And then what do I do after that? Well, or I can handle an exception. I'm going to skip that because this is just a simple example. But once I have a model object, I can just reach right into my view here. I could do that. That's totally real. This is a lot of our, a lot of very straightforward, simple app code would do this, but this is not good architecture. The one thing that all formal app architectures agree on is that your views should be completely separate from your data store. They should not know about each other. This is bad because the data store code is actually looking into the views. So while this works, it may not be the best architecture. So what we can do is add LiveData to add a level of abstraction between the data store and your views. So with LiveData, there's some things to know about it. LiveData objects are observable, meaning code can register observers to receive updates. So you attach your observer to it, and it gets invoked with each change. They're genericized, so LiveData objects must have some data type associated with them. The objects of that type will get sent to your observers. And they're lifecycle aware, meaning as your activity goes through its lifecycle, the observers will do the right thing. So, and I'll go over more detail about this in a bit. So if you want to keep your views up to date with LiveData, here's a scaffolding of a basic activity, and we've got some boilerplate here. We're inflating some views, we're pulling some views out of it. Now let's just say we have a LiveData object. And I'm being kind of hand-wavy about where you get it, but just imagine you have a LiveData object in hand, and it's parameterized by stock price. So we've got one of these stock price items with a ticker and a price in it. And we can attach an observer to it. It takes two arguments, and the first one is very interesting. The first one, you're actually passing an instance of the current activity to the LiveData. Now, normally you don't go passing around instances of activity to places because you'll leak them. But remember, LiveData is lifecycle aware, so it's using this activity to track the lifecycle of the activity. So hold on to that thought for a moment. We also need to pass an observer to it. The observer is going to receive stock price objects as it gets updated. And all we'll do here is check to see if it exists, and then we'll populate our views. So now we have a better level of abstraction here. We don't know anything about the data store. All we know is we're getting stock price objects. That's all we need to know. And we're just going to populate our views from this series of objects. Now, and like I said, LiveData is aware of the Android activity lifecycle. So when your activity goes through its on-stop, LiveData becomes inactive, and it doesn't notify observers anymore. So it kind of shuts down for a while, becomes inactive. But when your activity starts back up again, LiveData will become active and start notifying the observers again. And when your activity goes through its on-destroy, LiveData will clean up all those observers and eliminate everything, and everything can be garbage collected. So it's doing a lot of the sort of like grunt work of managing the activity lifecycle. All you do is attach observers to it. They're scoped to the activity, and they just work. So if I wanted to implement a LiveData object, I could do that very easily. All I have to do is subclass LiveData with the type that I'm interested in. I will also pass it a document reference. So this is a Firestore thing. This is a reference that points into the document, into the collection that I'm interested in. So I'm going to tell it what the document reference is that it should pay attention to. LiveData has a method you have to override called onActive, and this will get triggered when the number of observers goes from 0 to 1, or in other words, when someone starts caring what's in this LiveData object. So what I can do is go to that document reference and add my snapshot listener to it, then remember that I added it. Similarly, when the number of observers goes from 1 to 0, or nobody cares anymore what's in this LiveData, I can just remove the listener. So I'm basically trying to be optimized. I'm only listening when someone's listening to me, and then I'm unlistening when the last observer goes away. Now, I still have to actually listen to the document, so I can do that. The LiveData can be its own event listener. So event listener is an interface that snapshot listeners have to implement. So what I can do is just override that, and I'll show you the implementation on the next slide. So to implement on event, all we have to do is take a look at that snapshot. If it exists, make our stock price model object. That's fine. The important thing is I have to call set value on this LiveData with that object. What set value does is it tells the LiveData, hey, we've got new data to tell everyone. And it will turn around and broadcast that to all the observers. It'll also retain it internally. So if a new observer comes by, it'll get the most recent stock price immediately as it's attached. And of course, if there's an error, you should handle it. And I'm being a little bit hand-wavy about errors, but I'll talk about that later. So there's two problems here to resolve. Who creates this instance of LiveData? It has to come from somewhere, right? The problem is that the stock price LiveData constructor expects a Firestore implementation detail. So the activity can't create it. The activity can't know anything about document references. That would be too much information for the activity to handle. So we have to keep our views and our implementation separate. That's a must here. The other problem is that LiveData loses its data on a configuration change. So if I go through, if I reorient my activity, there's a configuration change, my activity gets torn down, everything in that LiveData will get torn down with it, which is okay, it's supposed to do that. But I'd rather retain that between activity lifecycle changes. So again, as you all know, when you reorient your device, you go through a configuration change, and that's a special case you want to handle. I'd rather have LiveData I'd rather have my LiveData available immediately. I'd rather not have to construct a new one every time there's a configuration change. So that's where ViewModel comes in handy. ViewModel is another Jetpack architecture component that survives configuration changes. That's like its whole reason for existence, is to be available once at the first instance of your activity and then persistently available as you go through configuration changes. They are shared and managed, so the system manages these things. You don't create one, the system creates one for you. And they're also lifecycle aware, so they're automatically cleaned up on the final destroy. So if we know the activity is never going to come back, that's this component's clue that it should just go away and be garbage collected. To visualize this a little bit better, imagine I have my stock tracker app. It goes through an orientation, there's a stock tracker app. It has a view model embedded into it. It's feeding the views. It's responsible for the data that's coming from my database. If I have an orientation change, now I'm in landscape, what view model will do is it'll automatically attach itself to the next activity. It's the same view model in the same state, feeding the same data, this time in a new activity. So what if I want to implement a view model? Well, I can do that by simply subclassing a view model. I can make my own API for it, so whatever data I want to expose in my view model, I can just make a method for it. So I'll make one called get stock price live data. Well, this is Java, isn't it? Get stock price live data, pass it a ticker string, and have it return that live data that we created earlier, that one that from slides ago. Now I want to abstract even further away the implementation details of the data store, so I'll create a repository interface. This repository interface can be implemented by Firestore, by real-time database, by what have you, it doesn't matter. It's an abstraction of where my data comes from, but without having to know where the data actually lives. So what I'll do in there is just delegate to my repository where to get this live data. So right now we have a very, very simple view model. All it does is expose one single method which delegates to the repository the responsibility of creating this live data object. So how do we implement this interface? Well, for Firestore, we can create a subclass, create an implementation that implements the interface, create that method that's part of the interface, and then reach into Firestore. So we're going to use that instance, and maybe I'll be opinionated and say this should be driven by dependency injection. And then I'll say, hey Firestore, in that collection, in that document that I'm interested in, get that reference and wrap that up in the live data object. So now what we've done here is we've completely abstracted away all of the details of Firestore into the repository. The view model doesn't even really know anything about this. It's just saying, hey, I have an instance of this repository, I'm going to delegate to it. So now we have four tools working in tandem. We have LiveData, which is doing the real-time, is the observable update dispatcher. We have ViewModel, which is holding on to these LiveData objects and making them available across configuration changes. We have a repository, which could be Firestore or real-time database. In fact, my app, I did both of them. I implemented both of them, so it doesn't matter where the data comes from now. And we have Firebase, which is the back end. Okay. So how do we put these four components together? This is a great team, but we have to assemble them somehow. So imagine we have this activity here. What we're going to do is assume our views are already handled. We're going to get a hold of a view model object. Now, there's a little bit of magic here, and the magic is happening in this little stanza. So we're going to ask this view model providers class to give me an instance of view model for the current instance of this activity. And then what I actually do is just pass it the class of the view model that I want. It'll be responsible for newing it up and giving it to me and reusing it in future activity instances. So this is just one line of code that's doing a tremendous amount for me. All I have to do is say, hey, give me my view model. I just need it now. Then I can get the live data from that. So now, using the view model, I've obtained a live data that may or may not be new. It could be from the previous version of my activity, or it could be a new one. We don't know. We don't care. It just works. Then we'll attach our observer to it. This is scoped to the activity, and then we'll reach into the views with the stock price object that we're getting from that. That's all there is in this activity. This is a very trim activity with a lot of real busy work that's hidden behind the scenes. Your activity is now completely and totally abstracted away from the data store. Now you're free to change your data store if you want. You don't have to change your activity. And in fact, you can do that. If you're running the app, you can actively switch between real-time database and Firestore, all through dependency injection and this level of abstraction. So what we've done effectively is implement this pattern. This diagram comes directly from the Android Jetpack architecture documentation, except we're not using Room here. We don't have like a persistence layer. Firebase has its own persistence layer. So when you're using Firestore or real-time database, all you have to do is flip on persistence, and there's a local cache on the device that's always ready to go. And we're not using a web service or retrofit. We're actually using Firebase as the remote data source. So this is what we just implemented. It's a great pattern, I think. So I was kind of hand-wavy before about how to deal with errors. I kind of left to-dos in there and some advice that you really should handle errors. And to keep the example simple, I skipped it. But you really should handle errors. So the thing to note here is that the LiveData I showed you, the LiveData parameterized by stock price, doesn't propagate errors. I can't get an error out of that. All I can get is stock price objects. But I need to bubble those errors up into the UI. I need to tell the user at some point, hey, there was a problem. You don't have permission. You're not connected or something. We need some way to let the UI know how it should be showing that. So what I did instead, and you'll see this throughout the sample code, is I have an abstraction called data or exception. And all this is saying I either have some data of type T or some exception. Not both, not neither, one or the other. And so I pass these around. All my LiveData objects shuttle around data or exception subclasses. So I'll just type alias and say I want a data or exception object that deals with both stock price and basic exception. And then what I can do is, instead of LiveData on stock price, I can say LiveData on stock price or exception. Then what I can do is, when I get my stock price or exception object in the UI layer, I can say, was it an error? Was it a stock price? Here's how I should manage the UI. So, there is so much more in the repo. This is like a 40-minute talk that had to be constrained down to 20 minutes, but go to the repo. There's a ton of good stuff in there, and I'm going to evolve this over time. My hope is that I'll have eventually a library that has all of the best components abstracted away so that you can use Firestore or real-time database and use good architecture patterns via Jetpack. With this, you can sync individual documents or nodes within the database. You can also synchronize queries. So if you want to query Firestore for a selection of documents, you can do that. And that selection of documents itself is live. So if any one of those documents changes, you can be notified. Or if the result set changes, you can be notified. Some of those patterns are not very well established in my app yet. So for example, the query, if you do a query and you want to map that into a recycler view, it's very inefficient. I just didn't have time to finish it. I'm going to evolve this over time. So definitely pay attention to the repo for updates there. Like I said, there's implementations for both real-time database and Firestore. You can use them both side by side. You can migrate from one to the other. Doesn't matter. They both work exactly the same. Except Firestore has better abstractions for changing data than real-time database was. I'll just mention that. There's also ways to do background sync with Work Manager. I wanted to do another 20 minutes on this talk just about Work Manager, but if you want to, say, ping your app and say, hey, go fetch something from Firestore or real-time database proactively, you can do that with Work Manager. And there's a whole backend here, actually, implemented in TypeScript for Node, and I've deployed that to Cloud Functions. So for those of you who track Firebase, you probably know Cloud Functions is Firebase's serverless offering, so you can write and deploy code that triggers in response to changes in your database. Super cool, super fun to work with. That's how all the LiveData in my app is working. It's actually a series of database triggers. That one triggers the other triggers the other, and it advances the state of my stock machine. Like I said, stay tuned for more. This is going to evolve over time. I'm going to give another version of this talk in the Android Summit, DC, in about a month, and again in DroidCon New York. So I'm definitely heavily invested in making these patterns work for everyone. That's all I have for now. Go get the code and talk to us over at the Firebase table. Thanks for your time.